Going to continue to look at roots. Now, sometimes you will come across what's referred to as a fractional exponent. And you will notice that here. You'll have a number at top, and then you'll have the number in the bottom of your exponent. Now, the number in the bottom of the exponent tells you the root you're taking. And that's what we notice down here in the color too. Now, the number in the top, right here, of the exponent tells you the power you're raising it to. Now, whether you raise your b value to that power before you take the root, or whether you take the root and then raise it to that power doesn't make a difference. So once again, the number in the top tells you the power you're raising it to. So on this next one down here, to write it as a root, we have a root of x. Now remember, the number on the bottom tells you the root you're taking. You're taking the fifth root, and the number on the top tells you the power you're raising it to. Now in this case, since our green 8's higher than our index of 5 in front, we can simplify it, but the directions only say to just write in radical form. It doesn't necessarily say to simplify it. Now in the next one down here, we got to basically do the reverse process. We need to go ahead and take our 6n and write it as something to a power. And so I'm going to put it all in parentheses because that 6n is all in our root. And then we need to go ahead and take a look at this. We're raising it to the third power. Sorry about that. That's the exponent. And then your index that you're taking, there's no index written, that's assumed to be a 2 then, is the denominator of the exponent. So now all we're going to do is just try to simplify this stuff. You should know here an exponent raised to an exponent, you need to multiply those exponents. And then it's just going to be multiplied by the rest of it. So now, since we're multiplying, and we can multiply in any order we want, I'm going to put my n's together. An n to the fourth times an n to the second. Remember, you have to add your exponents, you get this. And we would still have this here. And that would be our answer. We need to do the same type of thing over here on the right. Now, because we have parentheses, I'm going to apply this exponent to each one. Now, remember, when you're doing that, an exponent raised to an exponent, you'd multiply your exponent. So 7 over 4 times 2 would be a 7 over 2. On my y part here, multiply those exponents. 3 over 4 times a 2, because it's an exponent raised to an exponent, you'd multiply those, would be this. And then we go ahead and do this part here. Apply that 1/4 exponent to each part. And then on the y's, we'd have an exponent raised to an exponent, so we have to multiply. That's a 3 over 8. Now, once again, it's all multiplication, and you can multiply in any order you want. So I'm going to go ahead, and remember the exponent here is a 1. I'm going to go ahead and put all my x's together. And I'd have to go ahead and add those exponents. And you can do that in your head or on a calculator, and we would get this. And then I'm going to do the same type of thing with my y's. I'm going to add all the exponents on my y's together. And when I do that, I get 23 over 8. And so for the most part, that's what we do. Remember, we got to deal with parentheses and exponents first before we do our multiplication. So we're going to do the same type of thing here. Now remember, everything here is multiplication, and you can multiply in any order you want. So I'm going to multiply my normal numbers together. And then I'm going to take a look at my x's. And I just have to add the exponents on my x's. And then I'm going to come back and do the same type of thing with my y's. and I'm going to add the exponents on my y's. And I get 31 over 6. Now, keep in mind that we have a negative exponent. Remember that negative exponent, we don't want to leave it with a negative exponent, so that's going to move down to the bottom of the fraction and then become a positive exponent. And then we're still going to have that black. Now, remember, a fractional exponent is really a root, and we don't like to leave roots in the bottom. Now, whether you think of it as an x to the 1/4 or raise it to a power or write it as a root, as in being the fourth root, does not make a difference. And to tie it into what we were doing before, I'm going to write this as the fourth root of an x. Then you have to multiply by a special form of 1. Remember, that would be the fourth root of something. So that we can end up getting, remember, we want the fourth root of an x to the fourth because we want our index in front to match our exponent. So that would have to be then an x cubed. So our x to the first times an x cubed gives us our x to the fourth. Now, since I had fractional exponents, I'm going to write my special form of 1 as an x to the 3/4 on the top. So now I'm going to still multiply the top, so I'll still have my 8, I'll have my x to the 3/4, and I'll have my black, which is a y to the 31/6 over the bottom. Now, because my fourth index, the fourth root of x to the fourth, the index matches the exponent, they cancel, and that's going to just leave me with just an x. And so I'm going to write just x. Now, could you rewrite it all in the next line down? Yes. So we still have to be concerned about not leaving it with fractional exponents in the denominator and not leaving it with negative exponents. But a lot of times it's easier to combine things together first and then deal with any negative exponents and then look at if you have anything left in the bottom. So here, once again, it's all multiplication, and then you can multiply in any order you want. So I'm going to go ahead and multiply my normal numbers together. And then I'm going to go ahead and look at my x's and add those exponents together. And that's 11 over 6. And then I'm going to go ahead and look at my y's and add those exponents together. And that ends up being negative 7.5. Now, if you wanted to write it as negative 15 over 2, you'd be more than welcome to. But now, since we have a negative exponent, I'm going to have to move that down to the bottom. And then that would become a positive exponent. But now, I'm going to rewrite the bottom. So just a second here while I rewrite everything else. Now, the bottom would really be a y to the 11th, the 7th, times a y to the 1/2. Because remember, 7.5 is really a 7 plus a 0.5, which we could rewrite like this because we remember y to the power times y to the power, we have to add our exponents. So that y to the 1/2 is a fractional exponent. We don't want to leave that in the bottom. So we have to multiply by a special form of 1. Now, if you wanted to think of that as the square root of y, would not make a difference, but we would need to have a second square root of y, or a y to the 1/2 top and bottom to help us out with that. So when we rewrite this, we're going to still have our 9 on top, still have our x to that power on top, and our y to the 1/2 on top. When we look at the bottom, we're going to still have that initial y to the 7th, but now when we do this y to the 1/2 and this y to the 1/2, we'd add our exponents and we get a y to the 2/2 or a y to the 1. So when we have a y to a power times y to a power, like we do in the bottom, we could just write it as a y to the 8th power. And then I'd still have everything I had on top. We started out with fractional exponents, so I want to leave my answer with fractional exponents. So we have multiplication here again, and we can multiply in any order we want. So I'm going to go ahead and multiply the normal numbers together. Well, it's just a 4, nothing more we can do with that. And then I'm going to put my x's together. X to a power times x to a power. I'd have to add my exponents. And that's a negative 2.5 or negative 2 1/2, whatever you want to look at it as. And then I'm going to take my y to a power times y to a power, and I'm going to add those exponents, and I get y to the 0. Now remember, y to the 0 is 1. And so I'd have this timesing by 1, but remember, timesing by 1 doesn't make a difference. But I have in the blue a negative exponent, so that's going to go down to the bottom of the fraction and become an x to the 2 1/2. So on the top, it's really just a 4. Now on the bottom, we end up just having an x squared times an x to the 1/2 again. Because remember, you have to add your exponents to be able to get that 2 1/2. Now that x squared is not a fractional exponent, so I'm going to leave that alone. All I have to do is really go ahead and look at this x to the 1/2 because it's a fractional exponent, and we don't want to leave that fractional exponent in the bottom. So then you got to look at what do I have to multiply the top and the bottom by to be able to get that out of there. You can think of it as an x square root of x, and then you can do the square root of x top and bottom to help you out, because then you would square the red square root of x times the black square root of x would be the square root of x squared, which is just a normal x. Or you could think, okay, I have to go ahead and take that red 1/2 plus what gives me an exponent of 1 that I'm trying to get to. Well, 1/2 plus this 1/2 gives me that 1. So I'm going to do that here. So on top, I'm going to have that x to the 1/2 and then that green 4. Still going to have my x squared. But now, when I go ahead and go this times this, I get an x, and I'd have to add my exponents, and that would be an exponent of 1. So I'm going to have here the stuff on the top, and then I got to go ahead and take a look at the bottom. Go x to the power times x to the power, and I have to go ahead and add my exponents, so that's an x cubed on the bottom.